All right, students, so in the last video, you watched about the respiratory system, and we know the main problem the respiratory has to solve is how to get oxygen into the body to get into the blood, and then how do we get CO2 waste products out of the body using the respiratory system, which would be like the lungs and your throat and your nose. Exhaling and inhaling are how we accommodate both of those processes. This video is really going to start talking about this part, the blood. Okay, which we know is essential because we're using the blood like a highway system to deliver the oxygen and pick up the waste products from our cells. And if the cells don't get their waste products removed, it could be bad. I mean, it could kill the cells. It could impact you. You could feel sick. And in certain situations, I'm sure you could die, which obviously we don't want. So the cardiovascular system is what scientists use to call the circulatory system, which is made up of everything you see over here. So we have the heart, which is the main pumping mechanism that pushes blood in and out of your body. And then we have all of these veins and arteries and capillaries, tons of different blood vessels. So right now we're going to start filling in our notes, and we're going to be at the top of our note sheet. So we filled in the bottom part, and now we're going to go back to the top and fill it in. So the main function or job of the cardiovascular system is to be transporting materials like oxygen, nutrients, waste products, to and from the cells. And the blood is the main mechanism. Remember, it's like your highway system in your body. Your blood cells travel down the highway systems to do their jobs. All right, now we have our heart, which is our pump, the blood itself, and then the blood vessels, which are veins, arteries, and capillaries. Those are kind of the three main groups. So let's tackle the blood first. In an adult, there's 5 to 5.6 liters of blood. And if you're curious what that looks like, here you can see 2-liter bottles. So we have two 2-liter bottles that are completely full, and then we have our other half one. So this would be all the blood in your body. Now you guys aren't quite adults yet, growth-wise, so you're going to have a little bit less than that. And technically, blood is a type of connective tissue, which is kind of an interesting thing. Inside of your blood, you have a combination of different things. We have our white blood cells, which we know are made for our immune system. That's the main cell type of the immune system. Then we have our red blood cells, which are our delivery mechanism. They're going to be traveling down the highway, dropping off oxygen, and picking up CO2 and other waste products. So when you look over here in this beaker, you can see all the other stuff that's part of the blood too. So we have our red blood cells, our delivery people. We have our white blood cells, which are immune system, which is not surprising. It's only 3%. Then we have our platelets and our plasma, which both have a function. Plasma is the kind of the watery part of your blood. And then you can see in here, this is a cross section of an artery. So if you take an artery in your body and you cut it in half, you can see some of the stuff that's coming through. We have our platelets and our red blood cells, and it's all mixed together. All right, so red blood cells, their job is to supply oxygen. Here's what they look like underneath an electron microscope image. So they have a very unique shape, which makes them very dynamic because they have to flow and move through the body in these very tight little places. So they're small to start with, and then the shape really does allow them to scoot around pretty easily. They're made with hemoglobin. So if you take a red blood cell and you look at it really close, you have this protein fiber called hemoglobin, and that is where the oxygen connects to. So all these little blue circles here, those are all oxygen molecules that are going to be attaching to the hemoglobin because that's the main thing that they have to deliver is oxygen. All right, your bones are alive. We learned that last week, and this is where your red blood cells are going to be making. And they only have a lifespan of about 4 months. They have pre-programmed cellular death called apoptosis. So after about 4 months, they're not very good at their jobs anymore. So the body knows that, and then they pre-program their death. And then new ones are made to replace it. All right, platelets, which is another component of your blood. This is a clotting agent. So whenever you get an injury, whether it's internal or external, your blood can clot, which would prevent pathogens from getting in and blood from getting out. All right, so this is what a platelet kind of looks like up close. Has a really unique shape, which really helps it with its job. And then you can see here in an injury, so the skin has been injured, or I'm sorry, this is a blood vessel. Well, that's bad. We definitely don't want that leaking. So then your red blood cells will leak out, but then these platelets are going to clot up, and they're going to use their kind of sticky fingers. I always think of them like those things you can buy in the candy machines where you throw them and they're like ooey gooiness, and that they have a really unique shape to them, and then they're going to clot up. Okay, all right, the heart, kind of the main event. This is the big pump that makes up your entire circulatory system or your cardiovascular system. So you can see the heart is made of lots of different things. It's muscle though. Okay, this is a very specific type of muscle called cardiac muscle. The only spot you can find it in your body is in your heart, and it is a pump, and that is what it does all day long. And it's a very good pump because it has to be, or it can really affect how we live. Okay, so your heart is about the size of your fist. It's sitting almost directly center of your chest. So it's always interesting to me when people during the Pledge of Allegiance put their hand over their heart and they put their hand right up in the upper corner of their shoulder almost. And I'm like, wait a minute, your heart's actually in the middle of your chest, kind of the middle area. And again, its job is to take blood that does not have oxygen in it. We call that oxygen poor blood, and we're going to pump it to the lungs. Once that blood gets to the lungs, it's going to pick up oxygen. It's going to go back to the heart, where it gets pumped out to your body cells. So for every cycle, if we want to take oxygen from the air to the cells, we need our heart to pump twice for that cycle. Okay, so it's a really complicated mechanism though of how all the pumps work. So we kind of simplify it for 7th grade, and then you'll learn some more details as you get older. Okay, because again, we're going to take blood that needs oxygen, we're going to pump it to the lungs. Once it's at the lungs, it's going to pick up its oxygen, and we need the heart to pump again to get it back to the cells. So it goes from lungs to pick up the oxygen to the cells, and we need our heart to help pump it that way. There's 4 compartments or chambers for your heart. We have 2 upper chambers that we're going to call atriums, and then 2 lowers, which we're going to call ventricles. Now, kids used to have to memorize all this stuff, but this is why I say we have Google. In 7th grade, we don't need to memorize parts of the heart. There's really no purpose to that. Now your valves are going to control the blood going in and out of these chambers. They're kind of like doorways. Now we need these because we want to prevent blood from going backwards. Because each chamber has to have a magic pressure amount, a magic volume that it's filled with. For the valves to open and close properly. So we don't want blood flowing backwards or not filling it up properly. So we need these valves to control the flow in between all of the 4 compartments, the 2 atriums and the 2 ventricles. So here's what that looks like, okay? So first of all, the heart is color-coded based on the type of blood it's carrying. So if parts of the heart are blue, it's carrying blood that doesn't have oxygen in it. It's poor of oxygen. And so the main job of this part of the heart is to pump this blood that needs to get oxygen. We need to get it to the lungs. So it's going to flow in through the superior vena cava, fill the right atrium, force this open, the tricuspid valve, fill the right ventricle, flow up through the pulmonary valve, and then it's going to go through the pulmonary artery, and its mission is to get to the lungs. Okay? Once it does that, once it gets to the lungs and picks up oxygen, all right, it's going to turn red. Now in your body, it doesn't necessarily do this, but we color code it to make it easier. So from the lungs, the blood's going to flow in through the pulmonary veins, fill this left atrium, force open the mitral valve, fill the left ventricle, force open the aortic valve, and it's going to flow through the aorta. Now we're going to get delivered to the cells. Once that blood gets to the cells, it's going to drop off as oxygen, and then now it needs to get pumped back to the heart to get pumped to the lungs, to get new oxygen, and this process just keeps happening over and over and over. This is a sheep heart. So you can kind of see the little chambers here. It's not as detailed as ours is, but it's still the right idea. So you can see the valves opening and shutting right here. Well, it's open now, but it does shut. And then you can see the different chambers here. It's really kind of neat. If you ever have the opportunity, even to look at a deer heart, if you're a hunter, you can just kind of, I know it's going to sound gross, but you can just kind of cut it open, and then you can see this stuff. There's not much in the way, per se, of you seeing this information. Now, when you look at all of this thick stuff here, it's mostly muscle, but there is definitely some fat attached to it, and that builds up over time. But this is just solid muscle here, because all it does is pump all day long. All right, blood vessels. So these are tubes that are going to be moving your blood around. Again, this is the highway system that your blood needs to travel on to get to the cells and from the heart and all over the body. Your arteries are going to be carrying oxygen and nutrients to the cells and tissues from the heart. So you're going to be carrying blood that's rich in oxygen. It was already at the lungs, it already picked up its oxygen, and now it's trying to get to the cells to drop off everything. Capillaries are these teeny tiny, very small blood vessels that are going to be able to get really into all of the deep muscles and the deep tissues that make up your body. And then your veins are going to be carrying blood back to the heart where it needs to pick up new oxygen and drop off that CO2 waste product that needs to get out of your body. Okay, so when we look at all of this together, so we have both our arteries and our veins here, how long do you think all this whole highway system is? If we take it all apart, including all of our capillaries, which are these little teeny tiny little ones, and we put it all together, that will stretch approximately 100,000 miles long. That's all in your body right now. It's kind of amazing how much detail is put in here. You can see the arteries here, their shape, it's made of both muscle and connective tissue. Veins, same thing. Capillaries are just these teeny tiny little cell walls. And then your capillary beds, they kind of all grow together to get the job done of delivering that oxygen and picking up that waste product. Now, when you've gone to the doctor, you have gotten your blood pressure taken. Blood pressure is the force exerted by the blood on the inside walls of the blood vessels. So here you can see blood traveling through. This blood, as a liquid, forces and pushes on these capillaries and these arteries, all of this stuff. So your doctor wants to know how hard this blood is pushing on all of your stuff. Because if that number gets too high, there's too much force, there's too much pushing on your vessel walls, it can really hurt your heart. It can make it very difficult for it to pump. It stresses stuff out, and that can be pretty negative. Okay, so overall, you want your normal blood pressure to be between 120 over 80. And that top number is your systolic number. That bottom number is the diastolic number. And that deals with when they're taking your blood pressure. It's two different pressure points. Okay? So again, here is kind of the main event. Oxygenated blood is carried to all body cells where oxygen diffuses or moves into the cells. So we're dropping off the oxygen. At the same time, carbon dioxide is going to move from the cell and into the blood. So the blood dropped off oxygen and picked up CO2. That blood is going to get pumped back to the heart, where then it's pumped to the lungs. At the lungs, this CO2 that's in the blood needs to get dropped off and exhaled. And at the same time the CO2 is leaving, the blood is picking up new oxygen. And now we're going to do the whole process again. That blood then moves back to the heart, where then it's pumped out to the cells. We drop off the oxygen, we pick up the CO2, and then that blood is pumped back to the heart. Then it's pumped to the lungs, where we need to drop off the CO2. We got to get that out of the body through exhaling, and then we pick up new oxygen. And this is just happening all the time. Now, at the same time, oxygen and CO2 are moving around, nutrients are moving too. So we can deliver lots of things using the blood. Now, at the same time, your doctor might have used their stethoscope, which looks like this device. What they're listening to is how well your heart is operating. So every time those valves open in those chambers, it creates a sound. And you can use a stethoscope to do that. And scientists call that the blub noise, blub, 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 blub. And what that is your valves opening and shutting. And so we can listen to that to make sure those valves are opening and shutting all the way. And if they're not, then we would need to do more testing. Doctors would need to do more testing to make sure that that's okay. All right, students, that's the end of notes. So what you need to do now is you need to go back to Schoology, and your assignment, your inquiry question is waiting for you. You're actually going to tape an inquiry question onto the top of your notebook, and then you are going to work on that. All right, good luck. Make sure you do great work. I look forward to looking at your inquiry questions on Monday.